Now that we've set up the job, I can have multiple jobs. If I had geometry on this side, I would set up another job. When I go to remove the material off the bottom, I'll set up another job. And if I know that I'm going to have multiples, then I may just go ahead and say that this is for setup 1. All right, so if I am dealing with a lot of material or kind of a special case, I would offset this sketch or change the direction so that there's material above. A lot of times we're just taking 5 or 10 thousandths off the top to clean up the face. So um, we'll we'll kind of deal with that stock and that material as needed. And really, the intent of this introduction is to give you a sense of the process. I'm not really going to go through every step on creating the every parameter, every step on creating these programs. So just up front, we get to more of a programming situation, then we'll talk more about each of the settings. So a new operation and 2D milling going to the face is the same as going up to the cam, and 2D milling and picking, well, probably covered it up because my command manager is set to expand, so that's kind of interesting, or not. All right, so that's maybe something that will need to be addressed. I don't see the rest of the operations. So we'll go into the face, and you can either preset your library from the CAM, or as you go, or if you already have libraries, they will be showing up as a base. So if I wanted to use my VM6 library, I would just grab all of these, copy it, paste it into my part. Since we're just setting up for a some basic operations here, we'll do a flat end mill. Way too much is available because all of the sample libraries, or quite a few, yeah, all the sample libraries on the last load are active. So I'm going to see 5 or 10 of everything because we have inch for various materials, which should set the speeds and feeds. But if I create this library for mostly aluminum or steel, then it should have the speeds and feeds dialed into it as well. All right, so again, depending on which program you're using, the software has different strategies for managing those numbers. So let's see, diameter is, let's go with a 3/4 inch, so 0.75. I'm just going to grab the first one here and select it. It's going to put it into my grouping. And so if I wanted to make this kind of a local setting for this program, I can go back into the library, then tool 1, flood, carbide, 3/4 inch end mill, cutter sizes, lengths of cut. So since it's a little bit longer, that's going to generate an error. So if I go to 3 and 3.1, and then the feeds and speeds, we might be able to get to 600. And then your choice. I'm getting less particular about the 2 decimal places. It shows up on the control, but it really isn't hurting anything. And the feed per tooth at about 1.5 thou, it generates 18. That's maybe a good starting point. I'm pretty sure that I can run this tool at 30 inches a minute. I'll leave the lead in, lead out, so that I have a little bit of a safety factor. And the ramp feed rate, and I can override those at the machine if we really needed to. I'm not going to be doing any plunging, but if we in a situation where it plunges, oh, and then this will end up being a 3 flute, so that changes changes some of those numbers. And if I go 3 flutes times feed per tooth, that adjusted to the, all right, so adjusted the current feed rate, and now we're at 3 thousandths feed per tooth. And yes, we'll update the current, and when I select it, I'll see these numbers go, and anytime I use that tool, those will now be the defaults in this program. If I wanted it to be a global, I would end up writing it to my tool list or to the well, I think the standard tool lists, the system tool lists, are protected. All right, so one of the things that's going on here with these numbers is, again, you have quite a few selections depending on how you like to work. This is set up to where from the top of the model is added 200 thousandths, from the model top 200 thousandths. So depending on what this is, it's basically a logical operator. It's saying that we have the model top, the feed height will be at 200, the retract height will be at 200, and we can modify those depending on what we're trying to accomplish, and based on the selections. And then the clearance height is 400 above the retract height. So we'll see the tool come down to 600 thousandths, have a little bit of a pause, feed to 200 thousandths, and then plan its lead in. So if there was more material here that we had to contend with, then I might want to deal with the retract height as the stock top instead. But since they're the same at this point, then that works. In our cutting, it will be at the top, and the bottom, the cut depth, will also be at that 0 plane wherever we establish that. And at the work coordinate in the control, I'll step it down 10 thousandths or some distance. And then the facing operation goes to 90% step over. And depending on the machine and whether we're roughing or not, that may leave a good finish. It may also generate some waviness. So when we talk about the flatness, parallelism, also our surface finish of how fast when this is turning, what the surface finish in microinches is going to be. And as this tool moves across and loads and unloads in both directions, then that's what's going to generate the waviness. So maybe I'll go a little bit over half and do 400 thousandths, and that will reduce the waviness at least some, and then we'll have to determine from there. All right, so the direction by default will be 0 degrees, and depending on what it feels like, it may start on this end and go 0 degrees, or on this end 0 degrees, depending on the orientation of the model. We have a visual as far as the direction, and then how much over if we need to run the pass. So if I did not have the stock and I was just dealing with the part, but I knew I had maybe 100 thousandths over, I could extend the pass, and I can also extend the stock. And then directions, climb conventional, or both ways. Right? And then pretty much how is it going to lead into the part. And since I started at 200 for the retract, and I go ahead and set the lead in. So one of the, I would say, the unique things that as far as programs go that HSM does is it switches from G17, the XY plane, into G18 or G19, the XY the XZ, and the YZ, and or generates 3 axis to make this kind of arc lead in, which is nice, a little strange to get used to, but it kind of does the same thing as a ramp. All right, so I'm going to hit the tab key and hide the stock. And we have a facing operation that's going to establish the top. And then we need to come up with something for removing the material around the outside. So all of my speeds and feeds, I may come back and adjust the ramp feed rate if that is too aggressive or not aggressive enough. And then because of the associativity, I'm picking the bottom of the part. You need to pay attention to the arrow because right now it will cut the material out of the center, so I'll be reversing that. Tangent propagation and propagate along Z are going to determine if it goes all the way around or follows the radiuses. And then the height, and I believe I've changed these to where I'll have a 1 inch clearance and then 100 thousandths and 100 thousandths, so basically 100 thousandths above the part for it to start its lead in. And then 0 and from the model top, and at the bottom we'll go based on the selection. So I wouldn't want to pick up here because from contour would only take a little bit. It'd be much like the facing operation. But since I picked the bottom of the part, I want to go maybe 10 or 20 thousandths past to make sure that when I cut off the material on the back side that I'm not generating a aluminum or steel razor blade there, that it will actually remove some of that material. All of the systems are going to have some method of managing cutter comp, and so compensation and variations in the tool. If we go in computer, it will plan a 0 tool diameter and determine where the tool center line is. In control is you have to set the value, and it's basically programming to the edge of the part. Where is inserting the G41 and G42s to actually call cutter comp at a 0 tool diameter or tool center line, and then using that small variation to control the size of the part, so we can get very accurate, very close tolerance parts. Multiple finish passes. There is quite a bit of material there, but I'm not going to plunge the tool and go around in this case. So I might want to repeat the finish pass. Just let it take a spring pass because of the length, and then coming over to the defaults, rapids, keeping the tool down, lead in of 75, and lead out, which is fine, and then a ramp. So 3 degrees means that, or sorry, 3 inches, 2 degrees and 3 inches means that it's going to try to go one loop around in the part, which is pretty aggressive. Even if I was stepping in or stepping down, I would not be that aggressive. So we do want to see what it looks like. Well, I like a little bit closer for the start, so I'm going to put in the 30 thousandths, then we'll take a look. All right, so the 2 degrees means that it will take the 4 passes, and if that is too aggressive, then I would look at possibly a maximum ramp step down. Takes either the 2 degrees, I guess the greater of the numbers, and if I were to put a 1/2 inch in there, then I get 1 more pass. So I can kind of control the lead in. It starts going around. The advantage of the ramp is the tool has pretty much the same tool load throughout the entire cut, where a come to depth, lead in, lead out is going to side load the tool as it engages. Even with ramps and the other stuff, it's going around, it's leading off, it's stepping down. This is being a continuous path is a pretty good way to go. So I haven't left any material. I'm going to finish, but I will see the witness marks. So I might want to do another finish pass if it's not critical on the finish, or I could leave stock and come back around to finish up. So lots of options. Pretty much gonna go through and decide what you want the part to look like based on the tolerances and what you're given on the print. So let's move on to the to a pocket. And pocket's going to be a standard. We'll take a look at the adaptive clearing. So I set this at a, let's see, 0.25. We'll pick one of these. Right, so if I stay with my 600 surface feet per minute, which is pretty close, if I don't have a 10,000 RPM spindle, then the control is pretty much going to ignore this number. So I'm okay with 10,000 RPM spindle. 18 inches a minute should be pretty good. Right, so we go through and we would adjust these. The plunge feed rate and the ramp feed rate, that should be okay. We're going to plan for a helical spiral in. And then this is where those little radiuses in the corners came in handy because, well, the propagated along Z will find its way around, but if it was only a partial, or with the tangent propagation, then it would find its way through. Arrow is on the wrong side. Well, on a pocket it's all internal. So the question is, which way do I want it to finish? So this may conventional cut on the interior and then go back and do the finish. So got to kind of check those. We're setting from contour again, so whatever I selected is the depth, and then we would set the variation from there. Stock to leave, 20 thousandths on the sides. Most of the time will be 0 on the bottom unless it's kind of generating that waviness, or I need a more of a surface, and then maybe we'll go 80 thousandths would be about a third of the radial engagement. So we'll see what that looks like. And then lead in, lead out. Also, let's see, this is going to be the 2 degree starting from 100 thousandths. I'm going to set that to 300 so it's not doing loops in the air before it gets engaged in the part. And then we could also try and do the finish passes as part of the pocket, but I want to do a finish pass anyway, so that gives me my full width, full depth. So this first pass is usually the most aggressive and most likely to break the tool. So one of the things we would look at is possibly using this as a finish if we can be more aggressive and maybe have less of a finish with the adaptive clearing. So adaptive clearing is kind of a trochoidal cut, which is going to keep the tool engaged, should be able to run at higher feeds and speeds, but we're not going to end up with that full width, full depth first pass. So again, 100 thousandths, stock to leave. If I go 200 on the wall, 200 on the floor, or sorry, 20 thousandths on the wall, 20 thousandths on the floor, and we could let it go both ways. And that still determines load, unload, or how it's going to generate that surface. And so the main difference here is that we're going to see a lot more code. And so it comes back and forth, it makes a few maybe weird jumps, but the tool is evenly engaged across the whole cut. If I want to change the order of the operations, we do something like that, and then at last we'll do the finish. So a 2D contour, staying with the tool. I suspect that it will chirp a little bit in the corners, so we would have to address that with the feed rate. And again, checking for the arrow. I want to reverse, go on the inside. We'll find the lead-ins. Those are all looking good on the height. And once we've kind of set these and set the defaults, then we'll be able to just verify those. And then the wear to initiate the G41, G42, and the lead in, lead out. If I wanted to set an entry position, but chances are it's going to start in the middle and create the geometry. And then last would be a deburr operation. That I could set up a chamfer And most of the time, if I am just doing an edge break, I will use the chamfer operation. The contour makes a little more sense to me, that I haven't quite figured out the chamfer tool with an existing modeled chamfer, so it's like anything else you get used to. And so for the part here, we're going to go by type. We could set it up as, let's see if we have a chamfer tool. And probably going right past a chamfer mill. All right, so 1/4 inch by 45 degrees. If I didn't have the right size, then I would create one. All right, so 4012. Those will adjust a little bit. I'm not going to worry too much about that for now. I'll pick my outside edge. Make sure the arrow is going the right way. Pick the inside edge. Arrow is not going the right way, so we reverse it. All of those are going to be okay. Stock top is fine for what we've generated. Otherwise, I would switch it over to model top. The depth. So let's see, the chamfer width. I want about a 10 thousandths chamfer, and we'll go about 40 thousandths. So I should see the tool going to a depth of 50 as it figures out how to go through that cut, and then the closest that it will bring the tool into a possible collision is 25 thousandths, but usually I don't let it get that far. So I don't worry too much about the G41, G42 in computer wear here. I will set the heights out at the control, just using the length in the control. And then let's go with the 0.025 on the radius, the arc in and arc around. That usually works pretty good. All right, so that's going to be my edge break and deburr. And then our process is going to be stock simulation. Make sure that it doesn't do anything too weird. So let's slow that down. I'll turn off the tool and the holder, and could probably go a little faster. All right, so as it ramps down, it's removing the material. It takes one more pass. Ramp in with the trochoidal. You're going to see it make those circles, and this is going to generate a lot of code. Each one of those movements is an XY move. So, all right, and it'll get as close into the corners as it can, and then removing the material on the bottom. Then I'm not as concerned with the full width, full pass on the pocket. And if I step this over a little bit more, I'm going to still have a pretty decent finish and get pretty far into those corners so that I can fit my my square peg into that geometry. So it missed by just a little bit. And then the edge break, and we go back and make the cut. So I'd have to correct a little bit and see what's going on with the clearance for that tool, but that gives me a quick program to make this part.